All right. Hello, and welcome to from. We are at the here at Standup. With me are my co-host, Jake. There we go. Jake and that's three. And with us is Tristan from Camera Futura, who's going to be talking a little bit about how to go and use machine learning for automating photographer work.
Hey, Luis. Sorry to interrupt.
Luis, I think your mic is bad.
Ever.
Yes.
Classic. Well, I'll try and I think I know what Louise was trying to say. Welcome everyone to another edition of Machine Learning Community Stand-Up, .NET Community Stand-Up. Ironically, usually I'm the one with the bad mic. But today we've got Jake and Louise and me as usual. And our guest today is Tristan, who's going to be talking about his use of ML.NET and his software Futura Photo. So in his company, Camera Futura. Hopefully you all can hear us now. Louise, how are you sounding?
Is it better?
Way better.
Okay.
Better. Still a little distant, but we can actually hear you now.
It always picks up this mic here, but anyway, yeah, thanks, Bree. For second take was much better. Tristan, would you like to tell us a little bit about yourself and Camera Futura?
Yeah, sure. Thank you for inviting me today, by the way. So I started to work at Camera Futura 3 years ago because I am a photographer and I wanted to help a photographer. And I'm going to explain you today how machine learning and how ML.NET has made possible, let's say, to deliver the results I'm going to demo you.
Awesome. Yeah, super excited. I know personally, I wouldn't consider myself a photographer. I take pictures, but I'm not very good at it. But certainly I can relate to some of the issues that you're going to be sort of showing off and you know, showing how ML.NET and just machine learning in general, right, can help you with that. Mm-hmm. But before we get into Tristan's demos and awesome presentation, we're going to go ahead and show off a few of our community links. So let me go ahead and bring up my screen here. All right, there we go. So you can go ahead and get these links over at the URLs at the MLnet Standup 2021 8/18. So today's date. Let me zoom in just a little bit, make it easier to see here. We're going 150. We actually don't have many of them, but they are very, very interesting sort of demos. In this case, someone went ahead and created this Blazor application. I don't know if it's Blazor WASM or Blazor Server, but in any case, it's a Blazor application. And if you notice, what they essentially did was they built this UI or tool that kind of looks like if you play with, I believe it's called TensorFlow Playground. This is going to look very familiar to you, right? You have this these various inputs or parameters that you can sort of tune here. And then when you sort of set play, it will solve various traditional and sort of classical sort of computer science problems like traveling salesman, the 8 queens problem, things like that. And the way that it does so is by using genetic algorithms. So in here, there's a little bit more of a description on what genetic algorithms are, and essentially what the sort of some of the libraries that are used to build this application. So yeah, if you're interested in genetic algorithms in Blazor and to see how you can basically get these working together, make sure to give Blazor.ai a look. Let's see. The other thing that I wanted to sort of call out here is MLnet Documentation. So over the past almost 2 months now, John Wood, if you're familiar with John from his videos on YouTube, he's been working with us and helping us a ton to make sure that our documentation is up to date. So we know that in previous sort of stand-ups, we went over some survey results, and one of the top comments was that we needed to, or that documentation was a bit out of date. So John has been working, extensively with us to make this happen and make sure that our documents are up to date and they reflect the current state of the product, right? So huge shout out to John for helping us out here and doing a great job, putting together these updates and making sure that it's easier for you if you're getting started using ML.net, making sure that it's easier for you to get started with. And also just wanted to make another call out here. If you're interested in maybe taking a look at some of these doc updates or trying to get an idea of what it is that, or trying to get a sense of what exactly it is that we're planning on working on, and maybe it's something that you would be interested in working on and helping us out to update, you can go over to the .NET Docs repo. And if you search or filter by label here, it's the .NET-ML/prod. Label here, and that essentially will bring up a few issues here. Now, you may see a ton of them here. The reasoning behind this is essentially to make it easier to keep track of things that we want to work on. So don't be sort of, don't take a look at these issues and say like, oh, there's a bunch of issues or errors. These are more ideas and enhancements that we have for the documentation. And again, if you'd like to go ahead and sort of contribute, for example, if you wanted to contribute to this document on Azure training resources, you can certainly click into issue here and maybe add a comment or something here in the issue telling us that if this is something that you'd like to sort of contribute and help update. So, yep. Let's see here. If you are interested in learning a bit more about Camera Futura's use case, so Tristan here is going to go ahead and sort of demo a little bit more about this use case and walk us through what the problem is and sort of seeing, how machine learning can help you as a photographer sort of automate your workflows. You can go ahead and read about it here, which is basically the case study, business problem, and some of the solutions and why ML.net was chosen to solve this problem. You can read a little bit more about it here, but again, if you Tristan will be going into this a little bit deeper, later on in this episode. Let's see here, and that I think essentially brings us to the end of our community links for today. I think last time we didn't have a community stand-up, but one of the things that I shared was definitely go ahead and check out some of the F#Conf videos that took place. If you go over to the .NET YouTube channel, you can go ahead and check those out. So with that, let's switch over to this thing here, which is this new segment that I think we talked about in the previous episode or Machine Learning Stand-Up. And we said, what if we could do something like Sesame Street, where we have this episode was brought to you by the letter A or B or whatever, and then basically do a bit of a learning segment here. So that's what we're going to try to do here. We don't have music, so I don't know. Maybe I can, I don't know. I forgot the Sesame Street music. What is it? this episode is brought to you by the letter A. And A stands for, or area under the curve is something that starts with the letter A. It's actually 3 letters if you sort of shorten it, the acronym. But we're going to pretend it's only 1 letter, and we're going to work with area under the curve. Let me just go into this sort of full screen here, if I can. Of course, this is exactly what would happen all the time. Let's see, primary. Yes, awesome. All right, so area under the curve. Now, there's actually a lot of math that goes into area under the curve, but I'm not really going to get into the math. I'm really just going to talk to you sort of like conceptually, more or less, what should you be looking out for when you're looking at area under the curve. So typically, area under the curve, it's an evaluation metric to try to determine, okay, well, how well does my model perform, right? And typically, the types of problems that area under the curve is applied to or used to measure is classification problems, specifically binary classification. And the area under the curve is basically trying to measure the relationship between true positive rates and false positive rates. So what exactly are these? So true positive rate means that the actual value is true and the model predicted it to be true. So, for example, if you were giving some sort of medical diagnosis, that's kind of what you'd be able to determine that you correctly sort of diagnose something, right? Whereas false positive rate is more of a false alarm. That's basically telling you, hey, we sort of flagged this thing, and we think that it eventually took place. So, for example, again, in a medical diagnosis, we flagged this as, hey, this patient or this test showed that there was some condition, but it in fact was not. It really wasn't. So it's a false flag there, or sort of a false alarm there. And then essentially how you want to go ahead and interpret it is, if you look at this chart here on the right, basically a random model, which means basically how is it that, if you were to just flip a coin, right, you had, heads or tails. If you were to do that, this sort of green dashed line would represent that random model, where it's 50-50. It's just making predictions at random, right? A perfect model would be this red line here, where it basically predicts everything correctly every time. So there's no sort of false alarms, and everything is being predicted sort of accurately, if you will. All right. So that's why you see here in terms of how to interpret, your AUC of 1 means that it's a perfect model. AUC of less than or equal to 0.5 is random. And then this other blue line here, that's usually where most models tend to be, right? Where it's not really going to be a perfect model, but you're going to have something that's better than this green line here, right? So essentially, that's how you would, if you were to plot this AUC, that's how you would more or less interpret this graph here. So with that, hopefully didn't get too deep into what this AUC is, but if you are looking to interpret it and you're looking to basically try to understand what your models are doing, whether your model is good enough. Basically, try to look for things that look more like this blue line. It's unlikely that you're going to go ahead and get this red line. But yeah, so that's essentially what you want to be looking out for. So with that, let's go ahead and go on to Tristan here.
Okay, thank you, Luis.
Yep.
All right, so sharing my screen. Okay, so this is a website of Camera Futura, and just a few words about my work and what I have done. If you go to the website and if you go on the About section, on the company's section, you will see behind some links related to my professional background, what I have done as a photographer. So I don't want to spend too much time here, but I don't pretend being a genius when it comes to photography, but I like to take photography a lot. And that's how I started to work at this project. Basically, I am shooting something like 20,000 images per year, which is average for an enthusiast photographer. And I have several cameras. I have a drone. I am shooting underwater, outdoors, portraits. Some friend asked me to be their wedding photographer, and but I'm just an amateur, right? And I'm doing that for fun. But basically, as I can shoot 200 images per day minimum, I really to spend a lot of time when it comes to organizing the images I would like to post-process and to, let's say, this cutting process and to understand which images I'm going to archive and which images I'm going to post-process is very boring for me and has been very boring for me. So for years, I wanted to have a tool which could automate these steps before making the post-processing. A tool capable to help me choosing the images to be post-processed and the images to be archived, okay? And this is how I decided to start this Futura Photo project a few years ago. And for the last almost 2 years now, I've been also working with MLnet. I'm going to explain you more in details why. But I don't pretend being an expert when it comes to machine learning. And this is very important to understand because it means that even if you're not an expert in machine learning, thanks to MLnet, you can learn quickly the potential of machine learning, and you can execute it, and you can deliver some result for your application. So, which was really the reason for me to start working with MLnet, by the way. So, what I'm proposing for today is really to make you a short demo of the product. The idea is not to show you all the capabilities of what it can deliver, but more for you to understand how it works and what kind of stuff it is working at, so that we can really focus on how machine learning has been helpful for a photographer. So with that, I'm going to tell you a small story to illustrate what I am saying here. Okay, so let me give you this classic example. Let's say you would like to spend some days with a good friend of you doing some mountaineering stuff. We were supposed to be in Switzerland, but finally the weather was quite poor, so we decided to go to the south of France. And okay, we spent a few days here with a friend of mine, with a mountain guy. So we shot, let's say, quite a few images. Actually, there are more than 200. And as usual, we would like to share that with our friends. I mean, this time it's good to have some outdoors images to send some positive vibes to everyone who is suffering from lockdown. So it was quite important for me to share that. And as you can see from this, let's say, 200 images, finally, all I needed to really share with my friends was much less than that. It was just 10. Okay, so you see the stream very quickly. That's what it is. Okay, nice days. It was very funny. Good time together. Okay. That said, I need to post-process the images, so they are quite basic images. But I spent probably 2 hours making the post-processes, and before that, I would need probably 1 or 2 hours to organize this set of images and to really, let's say, focus at the right ones. So now let me show you how Futura Photo is helping me doing that. Okay, you see my screen. So basically, this is a desktop application. It's a full .NET application built on the .NET framework. Now I have migrated to 4.8, and I am planning to move to .NET Core in a few months, whenever possible, whenever relevant. And basically, the first time you are starting the application, it is asking you a few questions about what kind of photographer you are, so that the software can configure the rules which are here, because basically this is the tools which is going to take some decision according to rules. Do we archive an image or do we post-process it? Okay, and based on your answers, it's going to propose you a setup that you can of course configure and then you can improve. But again, for today, the idea is not to show you all what the software can deliver. It's more to focus at machine learning. So let's upload the files, okay, of the few days spent in the south of France. Okay, here we go. So basically, the software is going to analyze the different images, of course, based on the different rules that we were talking about. Okay, just let me do it again. This is a small one. Okay, we don't want to do that. We want to rather focus at, let's say, the full set of images. Okay, so let me try again. I'm going to select the full set of images. Okay, this is this one. Sorry for that. Okay, so now we have a demo effect as usual. Here we go. So the software is executing all the rules that are enabled according to your choices, of course. And as you can see here, it's starting to add some tags behind the images. So the idea was really to have a software which is going to work for you. So basically, when I am starting to analyze my photo shoots, I am just taking coffee, and when it is done, I'm back and I can start working at the images that are going to be chosen for the post process. In the future, by the way, we can imagine some Azure capabilities so that we can analyze on the fly with your different cameras linked to your smartphone to Azure, and you could do it lightly, right? But for now, I try to do it like that, so that the photographer, who can be people who are really reluctant to put any data on the cloud, by the way, can be sure that topics related to that for many photographers, and they can start working whenever they want, when they are traveling, for instance, so that they can analyze their images very easily. So you see there are quite a few tests actually, because if you think about what it means to have some good images, you need to understand that some images will be, let's say, flagged as poor because they are underexposed, because they are not sharp enough, but also because they are too similar. And similarly, you need to remember that for some enthusiasts who would like to, let's say, merge themselves what they are doing when it comes to panoramics, or would like to also make their time lapses themselves, it's important to have all the different files put together. So that's why it can be, let's say, quite lengthy to do everything. Okay, but I'm sorry, here we have demo effect because this is not normal.
So
okay.
while this is loading, Tristan, real quick. So as this process of this analysis process taking place, is it training a model? Is it like what exactly is happening to these images? Is it training a model, or is it using a trained model for those particular rules to basically classify and tag those images? What exactly is happening when this analysis is happening?
Yeah, so thank you for asking the question, Luis. No, basically on this version of the software, the idea is not to have, let's say, a model trained locally. The model is trained by Camera Futura, okay? And when the model has been trained, it is executed, but the model is not optimized for, let's say, the benefits of the user for now. However, in the future, it's very possible to imagine that depending on your choices, because you can, let's say, overrule some of the decisions, but you can also approve them. And depending on how you are interacting with the software, it's very possible to, let's say, have a model locally trained for the benefits of the user and customized for the user needs. Okay.
Gotcha. Yeah, no, that makes sense. And to reiterate, the application here, is this like a WinUI, a WPF? What sort of application is this?
Sorry, say again. Oh, it's
yeah, is this the application? Is this like a WPF desktop app? Winforms? What sort of application is this?
Yeah, exactly. It's a WPF application.
Okay.
Absolutely.
Gotcha. Okay. Very cool.
Okay, so hopefully it will work well this time. As it is a developer event, I'm sorry for that, but I'm not using the the production-ready version, the one which is released for commercial purpose, but the Nike build. So
Yeah, I mean, not, even without the software though, I will say that the photos are actually really nice. So I'd have a hard time picking through those. So maybe the models are a little bit more critical of your photography skills, but to me, they all look good.
Have, let's say, to open 2 other windows, one which is going to showcase the results. So basically, to have a view per rule, and you will have also one window to have, let's say, the photo view, the photo viewer for the full-size image itself.
Mm-hmm. Now, and in this case, I think I may have missed that. Are you applying all of the rules, or which rules are you applying?
Case that I'm demoing today, all the rules are enabled. Okay.
Mm-hmm, mm-hmm. Gotcha. Okay. And I guess I would imagine that the more rules that that it has to sort of go through, obviously, like the longer that it's going to take because of that, because it's multiple, I guess, models
Yes,
that
absolutely.
it has to. Yeah.
And here I am. Absolutely, and here for the benefits of the demo, I'm not using my development machine, which is, let's say, a powerful desktop. It's just, let's say, a Surface laptop, which is okay. And by the way, I can work with it when I am traveling, but usually I am working more on a more powerful machines when it comes to photography for enthusiasts.
Yeah, no, that makes sense. Now I see this works status here. It's saying acutance test. Is that what exactly are those tests?
Okay, so you have seen there are different rules, and on the acutance test, you have actually 7 different tests which are, let's say, passed to qualify whether an image is a failed one or is a success. And several of them are machine learning based ones. And the reason for that is because defining whether an image is sharp or blur is actually quite difficult. And the reason why it's quite difficult is because there are many corner cases. If you are familiar with computer vision, you know that there are a lot of, let's say, papers and methods when it comes to finding, let's say, whether an image is sharp or not. But when it comes to the real life, it's very difficult to be sure that your image are good or not. So that's why I needed to build my own machine learning models on top of some existing methods, because as you explained before with under the curve, I was under the curve and I had too many false positive, or let's say too many false negative. So you see, we have been go through all the tests when it comes to acutance, panoramics, eyes closed, duplicates, which are now executed right now. We are almost done.
Yep, gotcha.
And now as soon as it is done, we can have let's say, a closer look at the results themselves. Okay. So as you see here, if you go to check results, you are going to see, let's say, by rules, what is going on. So when it comes to images to be post-processed, you have, let's say, the images that the software expects to be post-processed. Of course, you can disagree with that. You can say, okay, this one I don't want. I don't want this one. I don't want this one. I don't want this one, and so on. Okay. Here you have the duplicates, which are grouped by similarity. It's useless, right, to add all the images together because they are too similar. And as you can see, the application has decided which image should be chosen according to many criteria like exposure, sharpness, and so on. So this is the same for the different groups of images. Okay. So it's quite fast, of course. For the panoramic, as you can see, some images are actually a merge of different images. So it is important to group them together because when you are shooting a few thousand of images, you need to really have the images grouped together. Okay. So here we don't have any time lapse in this example, no videos as well. We have a few images which are, let's say, overexposed. Okay. So they are detected as such.
Yeah.
Same for underexposed here. And we have a couple of blur images. If you have a closer look, you see it's blur. Okay, so just reject it. Okay, so when you are happy, you have chosen here where you're going to send, let's say, the images that you would like to post-process. and where you would like to send the images are going to archive.
Mm-hmm. Mm-hmm.
You apply the results. You can choose whether or not you would like to keep the sources, would like to delete them. Let's keep it simple.
Mm-hmm.
Okay, and that's it. And you can check the results. So basically, you have 65 analyzed.
Mm-hmm.
Some were moved, others were archived. You can check the results.
Mm-hmm. Mm-hmm.
Okay, and voila. Okay, so this was a very quick demo. Here you can see, let's say, the different folders. Okay, as you can see on the result ones, they are all together. So the panoramics are grouped together. So now you can work on them without being bothered whether or not they are panoramic numbers or not.
Mm-hmm.
And same for the successful images.
Mm-hmm. Gotcha. Yeah, no, that's really cool that it was able to run through all of these and pick out the best, and it seemed to do a really good job of that.
Mm-hmm. Exactly. Yes. Thank you. With that, I don't know whether there are questions from the community. Otherwise, I can be more specific on how machine learning is bringing value to the software.
Yeah, I don't see any questions at the moment, but yeah, let's dive into the code. Let's see how what's happening behind the scenes here.
Right. Exactly. Okay. So let me, for instance, explain you what we are doing with RAW plus JPEG. So I need to explain you what it is first.
Mm-hmm.
Okay, so as you may be aware, most of the people are shooting with just the JPEG file, okay? But also you have some people who like to shoot with the RAW file, so which is basically helpful for three main reasons. The white balance, so that you can choose where you want, the noise management, and the dynamic range. And there are pros and cons, of course. So some people, they like to shoot with both RAW and JPEG altogether, okay?
Mm-hmm.
So it means that for each image, you are going to have two images, one which is RAW, one is JPEG. So these people, for instance, when they are shooting 200 images, they are going to have 400 files. And what they are doing after each photo shoot, they are going through all the files, and they are keeping just a few RAW that they believe are going to be helpful, and they are deleting or archiving all the other.
Mm-hmm.
So the rule RAW plus JPEG is selecting automatically how, let's say, the software, how you should or not keep the RAW file. So basically, if you don't need the RAW file, it will tell you you should delete it. But if you need the JPEG file, it will tell you, okay, just keep it. And I'm going to showcase you exactly how I'm doing that. So in this example, for instance, this image is too green. Okay, you can see that it's too green, correct?
Mm-hmm.
Whether this image has the right balance.
Mm-hmm.
So when it comes to RAW plus JPEG, as I told you, you have different let's say, questions: dynamic range, noise, and white balance.
Mm-hmm.
Let me show you that with just a few images. Okay. So in these three examples, it's very slow today. I don't understand why, by the way.
No, it usually happens when you're streaming. Obviously it's taking some resources on your computer. I guess a question there, maybe you're going to go into it, but these, sort of green, being too green and, having the right color balance, is that information, are you pulling out the raw pixel data, or are you just, using some sort of image classification model saying,
yeah, exactly.
This is green?
Yeah, exactly. I'm going to show to explain you that. So you see, this is too blue. This
Mm-hmm.
one is has a dynamic range which is too broad. Okay.
Mm-hmm.
So basically, as you can see, finally the software can help you to decide here. Mm-hmm. It is telling you that this is a JPEG file, and you can see this is a JPEG file. So it's telling you need the raw file, so you can delete, you can archive the JPEG. Mm-hmm. Same for here. You can archive the JPEG file. You need the raw file because the dynamic range is too broad. On mm-hmm. that case, it's okay because you don't need to have the raw file. The JPEG file is fine for the same reasons. Okay. Mm-hmm. And now let me show you how I have built that, because for noise management and for dynamic range, it's easy to understand that you don't need machine learning. It's purely technical, right? You can measure noise on an image. You can measure the dynamic range of an image. So that's okay. But white balance, it's really a challenge. The white balance could be too green, too purple, too warm, and so on. And don't even try to measure it, because remember that if you have a problem with your white balance, it is because your camera has done the measurements the wrong way. And these people, I mean, Nikon, Canon, Fuji, Sony, and so on, they are smart people. So if they have failed, I don't think I can be better than them, right? So you need to have a different approach, completely different approach. And that's where machine learning, from my perspective, is super helpful by image classification, okay? So let me show you what I have done.
Yeah, and I guess, because in this case, right, like you are taking it with, I would imagine at the bare minimum with the point and shoot camera, maybe it's a DSLR camera or some other sort of camera, right? I would assume that this is probably what's happening. Like if you take pictures with your phone, right, I would imagine a lot of these corrections are taking place inside of your device.
Yes, they are, because it's JPEG files, and on your smartphone it's the same thing. Most of the smartphone now can also shoot with RAW file. So if you shoot JPEG, the smartphone or your camera, whatever camera, will decide how the white balance should be set up. And if it is wrong, you need the RAW file to fix that. If you don't have the RAW file, it's over. If you have, let's say, a birthday party and your smartphone is making the images too warm, they are too warm. It's over. You cannot do anything. But if you have the raw file, you can fix that, okay? So, okay, this is, you can see my screen?
Yes.
This is how, and how easy I'm going to build this white balance challenge, because I can tell you, I've been working for a long time before finding a way to understand how the white balance could be, let's say, estimated in a different way compared with what the camera is doing. So basically what I want to do, I have a photo object, okay, which is, let's say, my main object in Futura Photo, as you can imagine. It's a very complex class, but I have simplified it to the maximum, okay, with just a few properties, basically where the source file is located, and the likelihood of the white balance to be okay here, or to be too cold, too green, too purple, or too warm. And here I have an array, which is actually the same thing for the 5 combination here, okay? And that's it. And what I would like to do, I mean, in the perfect world, I would like to have a method which is going basically to calculate the white balance, thanks to machine learning, to return it, to estimate it, whether it is, let's say, photographies that need to be let's say, fixed differently because the white balance is either too cold, too green, too purple, or warm, or has been rightly calculated. That's really what I'm looking for. So the idea was really to train a model thanks to images classification. So what I have done is really that. I have added through the model builder the image classification scenario, okay? I have trained it locally. I have a set of data here which are really small. I think the first time I tried it, it was with more or less 1,000 images, okay? But here, for the purpose of the demo, there are only 40. So of course, you can expect a terrible performance with so few images.
Right.
But what was interesting was the fact that with typically 1,000 images, I had already a model which was quite efficient, and I could improve it over the time. And after, I would say, a few tries, finally, I think I had a model around 50,000 images. The performances of the accuracy of the model was above 92%, as let's say displayed in the ML builder. But actually, it's even better because remember, all I want to know is whether I need to fix the white balance or whether I don't need to fix it. So actually, it was closer to 95, 96%, which was my target.
Very nice. A few questions here in the chat. One is, so in this case, it looks like you trained for this particular, whether you want the RAW versus the JPEG. You're using Model Builder, but do you use other libraries like SciSharp or OpenCV for?
Yes. Yeah, absolutely. For instance, when it comes to typically eyes closed, okay, I am using OpenCV and DLib.
Okay, very cool.
Okay, yeah. I mean, it's for eyes closed, it's a mix of different things. For eyes closed, I had to use, of course, the classic models, but it was not enough because, as you can understand, I can show you something if you want. Typically, when you have, let's say, some images related to eyes closed, let me show you that. You see, here you have 3 models of eyes closed. On the right one, the lady is looking below, okay? So it means it's intentional from the photographer. Here, the young girl is blinking. I don't know if you can see. Maybe
Yeah.
Okay, you can see. So as the lady is blinking, it's a mistake, let's say. So you don't want to keep that one, okay? So I can discard this image. But here, it's intentional. So I have developed, thanks to DLib, and I have trained a model so that I can measure the head pose and the different angles, and I can decide, okay, this is intentional because as the model is looking down, it's different from blinking. So I should keep that one, and I can discard the other ones.
Very interesting. Yeah, right. Yeah, context definitely makes a difference there. So you can't just say eyes closed and call it a day. So
no. And I think it's a mix of 2 kind of different discussions. You have a business discussion, what it means to have eyes closed, is it good or bad? And then you need to discuss, let's say, how I'm going to build my model, what kind of, let's say, data I'm going to use to feed it when I'm going to build the pipeline, right? Because this is really where the business value will come from.
Right. Yeah, there's this other question, and I think maybe you'll go into it a little bit later, but Ronald here asks, how do you determine if a photo is overexposed, considering the dynamic range of a raw image?
Okay, good question. I thought a little bit on that one. When you have a raw image, let's say you have to suppose it's 14 bits, for instance. So you are going to measure the overexposition on the, let's say, the standard JPEG, which is coming from this image, but also you're going to measure overexposure by adding 2 EV or minus 2 EV, depending if it is under or overexposure on this raw file. So basically, you are trying to simulate the capabilities of your raw file because you cannot really measure it directly. You have to create JPEG. So the first JPEG will be, let's say, at 0 EV, so like it was exposed. One will be overexposed by 2 EV, and one will be underexposed by 2 EV. So for raw files, I need to measure 3 times whether or not it is properly exposed. Does it make sense?
Right. Yeah. So you adjust the settings to make it, for different exposure levels, and then you measure, how far off from each of those it is, right?
Exactly. But again, it is raw file. You cannot, let's say, work like it was JPEG. So you need to understand the capabilities of the raw file in order to measure properly the exposure.
Gotcha. And for that, just to, I guess, dig a little bit deeper, are those, so when you create those over and underexposed samples, are you just feeding those to the machine learning model, or are you using the actual values that you're getting from the raw, I guess, pixels or information data from the raw image?
No, for over and underexposed, it's not necessary to go through machine learning because basically it's purely technical. If you think about it, well, you could, because for instance, imagine that in the future, the user is going to discard manually or not some over underexposed images. So from that result, you can archive that, okay, and you can use it to train a model specifically for the needs of this user. But if you think about what it means, it's purely technical. So you have to measure. I mean, it's a luminance problem somewhere, right? You need to understand whether or not it's properly exposed. So.
Yeah, gotcha. Okay. I don't see Visual Studio blinking, so I don't think it's done yet. Training, right? Yeah, usually I think it blinks when it's done.
No,
Yeah,
it's
okay.
still training.
Perfect.
But it's really slow because before this meeting, it was just done in 3 or 4 minutes. So it's really slow.
Mm-hmm. Yep. No worries. So this is, to me, this sounds like this is one of the models that you have inside of Camera Futura. What are the other models, and do they work similarly, or sort of what are the differences? Are they all like image classification models, or do you have other more traditional classical sort of machine learning?
Well, I don't know if it is a traditional classical, but I've got this one.
Okay.
I have a k-means clustering.
Yeah.
I think it's a good discussion for today, by the way, because when it comes to, for instance, some difficult rules, let's take sharpness. Okay. I have different methods, as you can see, and I have results coming out of these different methods. I can use fuzzy logic, I can use thresholding, I can use whatever I want. I could not have a false positive rate, which was at the level I was looking for. Okay. So I was wondering, okay, let's try to train unsupervised a model when I'm going to put all this data and trying to, it's not a two-dimensional one, it's more, let's say 5-6 dimension, okay? Because I 5-6 test. And let's try to see whether an unsupervised model can put together 2 clusters, one cluster of sharp image and one cluster of non-sharp image, okay? Depending on all the data that I have collected from the different tests in the different, let's say, test images that I have in my database. And thanks to that, so I am adding one more test, if you prefer. I have done all my tests, okay? And after that, I am doing this test on a k-means clustering. I have got a result, and I'm going to use it also to make the final decision whether or not it is sharp or non-sharp.
Gotcha.
The other image are mostly image classification for now. That's correct.
Okay. Yeah. No, but it's interesting though that you're sort of mixing and matching, right? The different algorithms. Well, first of all, that you have multiple algorithms, right? It's not just this big one-shot algorithm or model that does everything for you. You have very specialized tasks that you need to sort of accomplish, and you have a model for pretty much for each respective task.
Yes, exactly. For instance, for the eyes closed, I have a delib based model, so C++ library. Okay. On top of that, I have a custom-made image classification to reduce the false positive rate, because in some cases you cannot measure the right way. Let's say how wide open the eyes are. So you need to have one more method, so basically a custom machine learning image classification model to retake the decision.
Yeah, gotcha.
I think that
sorry, go ahead.
Yeah, I think that in most machine learning cases, the challenge is to achieve the right false positive rate, correct? You don't want to bother the photographer. If you say, okay, the eyes are closed, the eyes should be closed, correct?
Right. Yeah, right. Yeah, exactly. You don't you want the tool to work for you, not, like you said, right, have all these false positives, and then you spend more time trying to fix what the app did or what the model did rather than focusing on what you're supposed to do, right?
Yeah, exactly. Yes. Yeah. Similarly on sharpness, as you can see, there are many corner cases. So different corner cases could be: are we dealing with out of focus images? Are we dealing with motion blur, mixed of them? And you need to have some specific models for each case. So again, it's a discussion between the business. Okay, what kind of scenarios do you have, and how you're going to find the right, let's say, setup in terms of models. And I'm trying to go machine learning when I fail to do it in a deterministic way for obvious reasons.
Right.
But maybe I'm wrong. Maybe you can try to do it straight machine learning just to see if you do not some good results. Why not?
Yeah. Right. Yeah. So we have a question here from Diego here. So we kind of talked about this where, with, let's say, your smartphone, you take a picture and, I assume that there's some machine learning that's happening to correct your image and, get the right settings to take the image. But could you or have you tried to apply these models that Camera Futura uses when you're taking the picture? So like not sort of when you sit down and you're getting ready to edit or post-process, but literally at the moment that you take the picture.
This is a very hype topic managed by different software vendors. By the way, it's not, let's say, the purpose of Camera Futura. We are not here to, let's say, to support the post-process steps. It's really before the post-process steps. But the question does make sense, because somewhere, if you can avoid to have, let's say, a wrong image, you don't need to archive them, because if you shoot, they are good, correct? In theory. But we are not yet there. And it's not, let's say, it could be very much, let's say, possible for a smartphone and for some very specific application. Remember, photographers, they like to keep the hand on what they are doing. So they don't want a software to facilitate that. They want to have, let's say, the full capability to choose whatever they want in terms of parameters during the shooting, because they want to have some special effects. So they want to decide on that.
Gotcha. Yeah. Because I mean, I could think of, right, like maybe not to get sort of that in between real time and before you do start doing your before you do the pre-processing and trying to select do the culling, using something like Camera Link or something like that, right? To hook up your image to the computer and then just take the snapshot on it almost in real time. Try to apply some of these models, but
absolutely. And again, there is nothing wrong here. I think it's a kind of future of photography, so again, you can really do it the right way. But it's a different topic, and keep in mind that enthusiast photographers, they don't want to have, let's say, a good image. They want to create their image, which is different. I don't want to say it's good or bad, but it is the way it works.
Right. Yeah. No, that makes sense. So you mentioned that you've been working on Camera Futura for 3 years, I believe, correct?
Yeah, that's correct. Yes.
Okay, 3 years. Now, was it always using machine learning, or was a machine learning sort of something relatively new? And if so, how was that process of introducing machine learning into Camera Futura?
At the very beginning, there were no machine learning, just because it was not needed. I started by the classic obvious rules like over under exposure, sharpness, the first sharpness test. And the more I was using the tools, and the more I was discussing with photographers, and the more, let's say, the needs were becoming more complex, like eyes closed, for instance. Okay, so very quickly, I would say after 1 year, it was obvious I would need to go through, let's say, this path of machine learning and to implement machine learning on the software. And at this time, I was wondering, okay, how am I going to do that? Because I need machine learning, that's obvious. But I can go with Python, I can go with other tools. And then I stumbled upon MLnet, by the way. As I am doing that in C#, it was quite obvious I should go with MLnet. And I started with a very trivial model builder to evaluate, let's say, the machine learning capabilities. Whereas at that time, I had a very limited knowledge of machine learning. So you can really check very quickly, just in a few hours, whether it makes sense for you and for your business. You could deliver some results thanks to the model builder. And when you get more familiar with that, you can, of course, forget the model builder, because there are some limits, as usual, when it comes to such builders. But at least you are being able to evaluate the potential thanks to it.
Yeah, that makes sense. Well, kind of like you're doing now, right? Where you took some images, you want to try something out with the white balance, and now that you've sort of defined your problem, now you just sort of providing your data to model builder to try and prototype and get something going to validate your idea.
Exactly. And stop me also if I am wrong, but there are with the model builder, you can use it mostly with the predict method, not that much with the transform method. Correct, Luis?
Yes, I believe by default, the code that gets generated for consumption uses the predict method, because I guess the expectation there is that you're going to be making a single prediction at a time.
Exactly. Exactly. So as soon as you would like to use the transfer method for different prediction, you need to go without the model builder anyway.
Right. Yep, exactly.
Okay.
Yeah. And that, I think that for the most part, it's a relatively minor change, right? But yes, you're right.
No, it's okay. And frankly, it was not difficult to go with the transfer method. I think the only part which was quite not challenging, but which was quite, let's say, a little bit difficult was the eye data view, if I remember well.
Right. Yeah. Getting your data into an eye data view.
Yeah. Yeah, but that was okay. Otherwise, quite straightforward to go that way.
Right. So sort of going along the lines of, the beginning and how Camera Futura was created. Renaud has a question here. Was the software created for just general photography, or can you use these algorithms also for, sports photos or capture images that are fast moving?
The idea was really to focus at enthusiast photographers, so people who are shooting different kind of images. Okay, sport photography, it depends. If you do it as a hobby, I believe that. I'm doing that myself, so I think you can use it for let's say such purposes. But if you are a professional sport photographer, you are going to shoot what, 2,000-3,000 images a day. It's a different discussion. So you need to have a very specific tool that's going to focus at, let's say, your main subject. For instance, if you're shooting cars or motorcycle, you need to have a tool that's going to, let's say, define where your motorcycle is located and to measure sharpness on it, and to do it so quickly because you have a few thousands of images per day to kill. So this is a very specific application. But I could do it in the future, yes, absolutely. But it's a very specific verticals when it comes to professional sport images.
Yeah, that makes sense.
Okay. This is just, let's say, what we're talking about, the transform method with the eye data view, but I don't know whether we need to go more in detail here.
Right, yeah. So in this case, and this is your application, the desktop application that we're looking at, and just showing how you could use the transform method.
Yeah, exactly, yes. Yeah, because I don't know if everybody knows, but it's very important to use transform methods as soon as you have, let's say, several predictions.
Yeah, exactly. Yeah. And Boss Fighter X, you can, yes, absolutely. So with ML.net, there's a few other libraries, but the library we're looking at here is ML.net.
Don't forget F#.
Yes, F# as well. So this is more on the application side of things and the packaging and deployment. Jose asks, do you use M6 or click once for installation for your application?
No, I don't have to.
Okay, gotcha.
So I have a question. Sorry if this was covered a little bit before, but I think you said you have multiple models that you're currently using. How is managing that going in your project? And is there anything like we could do to help with managing those multiple models? And how, I don't know, just do you have any feedback for us on that process?
It was not totally straightforward to do it, but it was not complicated by any means. My point is, if you have just one model, you can use a builder, and voila, it works. Okay. When you have more than one, you need to rename them. Maybe for the deployment could be a bit tricky sometimes. But I could try to be more specific on that, by the way. But remember also, I am using a .NET framework, so maybe this could explain that, right? And on .NET Core, it should be easier. Or I don't know during the deployment, but I was a bit, let's say, not surprised, but I was expecting to have some. It was not completely out of the box when you have different models, but frankly, it's not very difficult. Do you want me to be more specific? No.
If you have specific details, yeah, that'd be great. I mean, or we can follow up with more conversations and learn more about your process and maybe what pain points you had. But yeah, Awesome. Thanks so much for sharing.
No, because I think we should differentiate whether it's specific to my issues with typically a .NET framework, or whether it's something that I missed. And from here, I think we can try to double check whether these multiple models on one solution could be streamlined in a better way or not.
Awesome. Yeah, let's keep the conversation going.
Yeah, sure. You're welcome.
Oh, Luis, you're muted.
That's exactly what would happen. I was saying I didn't realize that we are at time. It just flew by here. Just checking out the app and all this things that it could do. I mean, like I said, I know myself. I definitely want to try it because, there's a lot of pictures that are not good that I take. So I'm hoping at least this can help me narrow them down, whichever my good pictures are.
But it's assuming that you have at least one good photo, Louis.
I hope that I have at least one good photo.
A good image is something very, let's say, difficult to qualify when it comes to, let's say, your personal, let's say, taste as a photographer.
Right.
Totally.
Yeah. I mean, I know I can't take pictures as good as the ones you showed here, but I try.
As soon as I heard about it, I immediately had to tell my wife about it. Basically, as soon as I started working on ML.net, she's like, just tell me when there's something I can use to help me, pick out the best photos and stuff like that. So I was super, super excited that it existed. It was using ML.net, and now she can start using it for all of her photos.
Yeah, absolutely. And you have a free version, so you can try for no cost. And you have all the features enabled, so it's very easy.
Awesome. Any last sort of parting thoughts, Tristan, before we sort of close this out?
No, I think everybody is free to contact me, by the way, as a follow-up when it comes to photography or when it comes to, let's say, machine learning. And I'm happy to have, let's say, some follow-up on that topic. And again, the future of such topic also will go through cloud discussion with cameras more connected to the cloud. But again, it's not me, it's more, let's say, the photographers. So for now, it's a community which is quite reluctant to go to the cloud so easily when it comes to their own data. But that being said, I'm sure that in the future, it will be much easier, again, to organize your images and to focus on the right ones.
And Tristan, do you have a Twitter, either your own or one for Camera Futura that our followers can follow?
Absolutely. I've got both. So don't hesitate to follow me on that. So the first one, you want me to show
let's
that?
Either pull it up or we can put it in the chat so that we can send it out and people can give you a follow.
Okay, sure.
And while you're pulling that up, someone did ask about Torch Sharp, and I want to address that just really quickly. They asked, hey guys, what happened to Torch Sharp? Is it discontinued? No, it's not actually. There's some new stuff that's going to be coming up soon, and I'm assuming in one of our next few community stand-ups, we'll kind of talk about the future of Torch Sharp and how it's going to play into our deep learning story in .NET. So stay tuned for that. And Tristan, do you have your?
Yeah, I'm right. Just a second.
Awesome. And if anyone has any last questions while he's pulling that up,
yep,
feel free.
And I'll just call out if you have an interesting project that uses machine learning and .NET, and you'd like to showcase it, definitely feel free to contact us, and we'd be more than happy to, sort of showcase all the awesome work that you've been doing. Awesome.
Oops. Louise, you want to, it looks like just posted it here.
Yeah, I'm just going to post here into the chat, and then I'll also go ahead and bring up the banner here. So Tris Romain is the handle.
Ta-da.
Thank you.
There we go. Yeah, well, again, thanks so much, Tristan, for showing this off. Again, it's a really cool application. We really appreciate having you on. I hope folks learned a bit about, how you can use machine learning to solve sort of real world problems, things that you may not think like off the bat that, this would be a really good use case. or how you might even go about integrating it, right? I think you showed us that machine learning can help with that. So again, thanks so much for coming in and showing us your app. Thanks for everyone for tuning in. And with that, we'll see you in 2 weeks.
Thank
Take
you.
care, folks. Bye.
Bye-bye.